The next set of videos will cover the topic of alcohols, which is part of the organic section of the syllabus. We're going to look at first the naming of alcohols and then how to classify alcohols. So alcohols are organic compounds that contain the hydroxyl group and OH group covalently bonded to a carbon atom. So don't confuse the hydroxyl group with hydroxide ions. Hydroxide ions exist in ionic compounds like sodium hydroxide or potassium hydroxide. These are ionic compounds that will ionize in aqueous solution to give ions. These are not alcohols, these are metal hydroxides, and these are ionic compounds, and they ionize in aqueous solution to form hydroxide ions. Alcohols are not ionic compounds, they are covalent compounds. The hydroxyl group is not an ion, it is a functional group that's covalently bonded to a carbon atom. So don't confuse hydroxyl group, which are found in organic compounds, with hydroxide ions, which are part of ionic compounds. So let's name some alcohols. The simplest alcohol is this one here, and it's got one carbon, so it's based on methane. So the parent compound would be methane. And because it's an alcohol, it's got this hydroxyl group. So we take away the E on the methane and replace it with OL for alcohol. So we write OL for methanol there. So that's methanol, the simplest alcohol. So this next one here is based on propane because it's got 1, 2, 3 carbons. So the parent compound is propane, or parent alkane is propane. We take the E off the propane and replace it with OL for alcohol. So that's propanol. We can even be more specific because we can have another type of alcohol with 3 carbons, and this will be a different type of propanol. So this one we call propan -1-ol because the hydroxyl group is on the first carbon, and we want the lowest number for the functional group, which is number 1 here on the first carbon. So remember, we use dashes to separate letters and numbers. So here's a dash that separates a number and letter. So this one here will be propan 2-ol because the hydroxyl group is on the second carbon. So these are both isomers of propanol, and they are structural isomers of each other. So here we got a cyclic alcohol, and its parent alkane is cyclohexane. So we start with cyclohexane. We take the E off the alkane and replace it with OL. We don't need a position number because there's only one OH group and there's no other functional groups on this compound. So this is cyclohexanol. If I add a side chain here, in this case an ethyl group, we're going to keep this as position 1 because that's the parent compound, which is the alcohol. We want the lowest number for the parent compound, which is the alcohol here, that's position 1. So this ethyl group must be on position 3. So this will be called 3-ethyl cyclohexanol. So there's no comma, we're not separating any numbers using commas here. We have a dash that separates a number and letter. So this next one here has 2 hydroxyl groups. So we're going to name this based on the parent alkane, which is 4 carbons. So that's based on butane. We take the E off the parent alkane and replace with ol for alcohol. Because we got 2 hydroxyl groups, this is called a diol for 2 alcohol groups. So we put di in front of the ol. We don't like to have a constant following a constant, so we put an E back in from the parent alkane. So we've got butane diol. Then we put the position numbers of where the hydroxyl groups are, which are positions 2 and 3. So if we count this direction, this is 2, this is 3. If we count this direction, this is 2, this is 3. So it doesn't matter which way we count. So we put dash to separate a letter and number, comma separate 2 numbers, and then dash again to separate a number and letter. So this is butane 2,3-diol. The next one, we have 2 functional groups. We've got the hydroxyl group for the alcohol and an alkene double bond group there. So we call this an enol, so the ene comes from the alkene and ol for the alcohol. And to name this enol, we're just going to follow some steps. So the first step is that we got 1, 2, 3, 4 carbons in the parent alkane. So we start with butane. we have a double bond here, so this would be butene instead of butane. And then we put the position number for the double bonds, that is but1ene. So again, we separate a letter and a number using a dash, there's no comma. Then we add the alcohol into the name. So this is on the third carbon, because if the alkene is the parent compound and this is position 1, this must be carbon 1, this is carbon 2, this is carbon 3. So we must count in the same direction as for the position of the double bond. So we add O to the end of the name to show it's got an alcohol. Now, once we add the O, we don't like two vowels following one another, so we take off the E on the alkene. So we got NO, and then we put the position number of the O in the name, which was position 3. You can also swap the positions of the alcohol and the double bond as well, so you can call this. So if we consider the alcohol as the parent compound, that will have the lowest number for the positions. So this will be position 2. So if this is carbon 2, this is carbon 1, this is carbon 3, this is carbon 4. And the double bond then would be the third possible position, because this would be position 1, position 2, position 3. So we have 3N for the third position of the alkene and 2O for the second position on the alcohol. So either of these names will be acceptable. Perhaps this one will be better because we've got the lower numbers. So we have but1ene 3O or but3ene 2O. In some cases where the compound has more than one functional group, we sometimes use a different name for the alcohol if it was easier to name the other functional group as a parent compound. So for example, here we've got a carboxylic acid group, which we'll look at later in detail. And this is easier to name if we use the carboxylic acid as the parent compound. So this compound is based on propane because there are 3 carbons in the chain there. And we take the E off to replace it with oic acid. So the carboxylic acid is named as oic acid. So this OH group, the hydroxyl group, is considered the side chain. So when we call the hydroxyl group as a side chain, we call it a hydroxy. So when we use a hydroxyl group as a side chain, we use the prefix hydroxy. So this is hydroxypropanoic acid, and we want the position number of the hydroxyl group. So because this is the parent compound, this is carbon 1, this is carbon 2. So this is 2-hydroxypropanoic acid. And the common name for this is lactic acid, which is the same acid produced in your muscle cells undergoing anaerobic respiration. I mentioned chloroquine when we did haloalkanes because it's got a chlorine, a hydrogen group, and there has been another compound which is very similar to chloroquine, which has fewer side effects than chloroquine in possibly treating COVID-19. So that's called hydroxychloroquine, and the name then tells you there's a hydroxyl group, and the hydroxyl group happens to be here. So that's hydroxychloroquine. What we're going to do next is look at how we can classify alcohols into primary, secondary or tertiary alcohols. And we need to be able to do this because different types of alcohols or different classes of alcohols will react differently under the same conditions sometimes. So a primary alcohol is where the hydroxyl group of the alcohol is bonded to a carbon, which is bonded to at least 2 hydrogens. So methanol is a primary alcohol because it's bonded to 3 hydrogens. So propan-1-ol here is also a primary alcohol, and so is ethanol here. You can also have primary alcohols where there are branching, but the OH group is still bonded to a carbon with 2 hydrogens. So here again, this is a primary alcohol because the hydroxyl group is bonded to carbon with 2 hydrogens here. Secondary alcohols are alcohols where the hydroxyl group is bonded to a carbon with only 1 hydrogen bonded to it directly. So we've already seen some secondary alcohols in the examples I gave you earlier. So propan-2-ol is a secondary alcohol. Cyclohexanol is also a secondary alcohol. The hydroxyl group is bonded to a carbon with only 1 hydrogen bonded to it. So here we've got a diol where both the hydroxyl groups are bonded to a carbon with only 1 hydrogen bonded to it directly. So this is a secondary alcohol, and so is this. We saw lactic acid earlier, which is also a secondary alcohol because the OH group, hydroxyl group, is bonded to a carbon with only 1 hydrogen directly bonded to it, because these 2 bonds link to carbons here, which are not hydrogens. So unless you're falling asleep by now, you probably worked out that the tertiary alcohols are alcohols where the hydroxyl group is bonded to a carbon with no hydrogens bonded to it. So here's a situation where we got a primary, secondary and tertiary alcohol. So here we've got a primary alcohol here, a secondary and here's a tertiary one. You can also classify alcohols in terms of the number of alkyl groups that is bonded to a carbon bonded to the hydroxyl group. So for example, a primary alcohol would be one where the hydroxyl group is bonded to a carbon with only one or no alkyl groups bonded to it. A secondary alcohol would be one where the hydroxyl group is bonded to a carbon bonded to two alkyl groups. And a tertiary alcohol would be one where the hydroxyl group is bonded to a carbon bonded to three alkyl groups. So we covered in this video how to name alcohols and also how to classify alcohols into primary, secondary or tertiary alcohols. In the next video, we're going to do a very short video on physical properties of alcohols and explain them in terms of hydrogen bonding.